Alright guys, here is your tutorial on how to complete your drawings for the circuits. So make sure you read the procedure. It's explicit. And here are your parameters for each circuit. You're going to be drawing 3 in total. Okay, the first one is going to have a voltage of 3 and a resistance of 4. The second one's going to have a voltage of 7 and a resistance of 5. And the third one's going to have a voltage of 5 and a resistance of 2. All right. So here is the PhET simulation that you guys should have pulled up. Now, I'm going to start. Make sure you just select the tab on the left. That's the actual picture of whatever object we're using. It's nice to see it first. All right. Now, I'm going to go ahead and grab a wire. Grab another wire. Okay, mix it around. I grab another wire, put it here. Okay, and put another wire, and yep, there's my circuit. Okay, is this a completed circuit? The answer is no. You don't see these electrons. Notice how I've clicked the electrons here on the right. Those little blue circles represent the electrons. Nothing's moving. Why is that? Well, the reason is there's nothing pushing the electrons through the actual wires. There's no voltage source. Remember, voltage, if we define voltage, we defined it as the ability to push electrons through, right? So we need a voltage source, okay? And that's where the battery comes into play, okay? The battery is a voltage source. Well, how does that work? How does a battery work? How is it a voltage source? Well, we have these chemical reactions happening inside that battery that creates this electric potential difference. And when we create that electric potential difference, it's actually able to push electrons through the actual circuit. Okay, now I'm going to go ahead and cut this so I can fit this in. If you hold it at the corners, you can press the little scissor icon. And I'm going to fit this battery in here like so. All right, I got some flow. But notice that my circuit has been shorted. This is called a short circuit. Okay, why did it catch on fire? Well, it caught on fire because this flow, this current is way too strong. It's way too high. So a short circuit is too low of resistance. It's a circuit that has too low of resistance, and it creates too much heat as the electrons flow through it, and it can be dangerous, and it can create something like an explosion or fire. Okay, so what do we need to do? Well, we need to have some resistance or increase the resistance, and we can use these resistors to do so. So I'm gonna go ahead and cut this. All right, now when you select the resistor, you have a little tab at the bottom, and you can actually toggle the resistance. Okay, same thing with the battery. If you select the battery, you can toggle the voltage. So if, in fact, we go back to our directions, the first one that we need to build has a voltage of 3 and a resistance of 4. Okay, so back to this tab. So let's go ahead and I need 4 here. 3, 4. Oh, there we go. And then voltage of 3. Sorry. There we go. All right. We put that in. You can put that anywhere else. Let's make it a little bit more visually appealing. I'm going to cut this. Boom. Move this down. Stick the resistor here. Move that up. Move that back. I can change the angle. All right. There we go. There's our circuit. Notice how electrons are flowing from the negative end into the positive end of the battery. That's how electrons actually flow. Okay, and as they go through the circuit, as they move through the wires, it moves through the resistor. Okay, and that's why our flow is not as strong. Okay, it's not as strong. We have some more resistance. Remember, it acts as a speed bump, right? Okay, so what you can do now is you can grab your voltmeter and you can actually check the voltage. If you put an end on each terminal, boom, you get a voltage. Okay, you can just use it as a positive value. But that's because I put them on the wrong ends. We'll just give a positive value. You can keep your value positive. 3 volts, that's what we wanted. Okay, and then our ammeter right here, we can put right on the wire and it tells us how many amps are running through it. That is the current. All right. Now, I want to show you guys something. If you select this tab at the top right, it says conventional. Notice how the flow is now moving in the opposite direction. Well, back in the day when they were studying electricity and circuits, they did not know the charge of an electron. They actually thought the electron, or whatever was flowing through this system, was positive. And it really doesn't matter, but we as physicists and engineers, we keep utilizing that conventional method in order to keep things consistent. Okay? In actuality, we know that electrons are actually flowing in the opposite direction. And once again, that's because the charge of an electron was found after the fact. But we had already been drawing things the conventional way, so we're going to keep drawing it the conventional way. I will be specific on an assessment. Say, hey, draw it the conventional way, or draw it in the electron notation. Okay, I will let you know what I want. All right. Now, last thing, when you do draw these, I want you to draw them as symbols, because that's what we do as physicists and engineers. Is we don't actually draw batteries. We're not artists. Okay, so if we utilize symbols, it's a lot easier to draw these things. So notice the symbols for each of these are up here on the left side. All right, you're going to be drawing this exact model or whatever you created on your paper in this symbol notation. Okay. All right, so you're going to do the same thing, just you're going to be messing with the voltage and the current for the other 2 drawings, and then you can kind of mess around with it and get familiar with simple circuits. All right, hope this helped.